This is explanation of how to do question number 4 on the reaction direction reading guide from pages 632 to 637. Hopefully students were able to figure out what reaction quotient is. That is the capital letter Q. Basically, you're doing products over reactants for any time other than at equilibrium. Question number 3, hopefully students were able to identify you need to take the square root of both sides to simplify to solve for x. But solving for x is going to be one of the main skills mathematically we have to do. I'm going to move on to question number 4. Where it gives diatomic bromine forming 2 bromine atoms, and it gives you an initial concentration of each. Remember, when we're doing an ice table, you need the concentration values for each thing, not simply just the number of moles. If you're given the number of moles, hopefully you're also given the volume, so then you can divide and actually solve for the concentration. First thing I would do in a question like this is I need to determine which direction is the reaction going. In order to do that, you can solve for Q. Q is the products, 1.2 times 10 to the negative second squared over the reactants, 6.3 times 10 to the negative second. In this particular case, Q would then equal 2.3 times 10 to the negative third. Comparing that to the K value that I've been given at the top, what I typically do is I have K, I have Q, and it looks like in this particular case that the K is smaller. The reason why I put it that way is my greater than or less than sign can also be used as an arrow, showing that the reaction is going in that direction. So remember, K comes before Q alphabetically, so if you are trying to figure out the direction of the reaction based upon the reaction quotient, put the K first, then the Q, then use your greater than or less than sign. Since the reaction is going to the left, that means I'm losing the BR. I'm using a 2 there because it is a 2 to 1 ratio. Therefore, at equilibrium, I have, and I'm just going to write this out as scientific notation, 0.063 plus x and 0.012 minus 2x. In order to solve for x, I'm going to set up my K equals BR squared over BR2. So, K is 1.1 times 10 to the negative third. That will equal 0.012 minus 2x squared over 6.3 times 10 to the negative second plus x. This question requires a lot of mathematical work. In order to help out with this, I will simply write down what you would get. But remember, if you are squaring something, you need to square this, you need to square that, but then also you need to multiply these two things and then take it times 2 as well. So simplifying this would give me 1.44 times 10 to the negative fourth. That's the 0.012 squared part. Plus a negative 0.048x. That's multiplying the 0.012 and the negative 2x and then doubling it, plus 4x squared, all over 6.3 times 10 to the negative second plus x. The next step in order to solve this is to get rid of the numerator. Multiply both sides by 6.3 times 10 to the negative second plus x, so I don't have to worry about things at the top and the bottom. Again, I'd help out with that. Okay. If we have an equation with both x and x squared, what you need to do is to get everything equal to 0. So get everything on one side of the equation. I prefer to keep whatever has my x squared value as a positive value. So I'm going to add everything from the left side to the right side. So 0 will equal, and I'll just change the order of this then, 4x squared plus a negative 0.0491x plus 7.4 times 10 to the negative fifth. Hopefully you're taught in a math class if there's an easy way then to separate these out into an x plus something and another x plus something you could solve from there. I'll tell you right now, this one is not an easy one to solve. And if you can't factor out, there's only one other way to solve for x. And that is an equation that hopefully you are familiar with. The quadratic formula. A is the number that's in front of the x squared. B, don't forget if there's a positive or negative, is the number in front of the x. And C is the number that does not have a variable in front of it. Some people actually program this into their calculator, so if they can write down the formula 4x squared plus the negative 0.0491x plus 7.4 times 10 to the negative fifth, it'll just plug it in for them right away. I'm going to save us the time of plugging this in and show you the two values that it can equal. If you're unsure of why it can equal two values, it's because we have to add all this or subtract all of that in order to get it to work. 0.00178 was one of the x values, or 0.0105 was the other x value. Only one of these answers will actually work. And the reason that only one of these answers will work is if we go back up to the top here, if we have 0.0105 as one of our options, and we plug that in right here, if we plug that in for x, this would give us a negative value at equilibrium. And there's no such thing as a negative concentration. So usually what happens when you use the quadratic formula is you're able to rule out one option. Now that we've solved for x, we're not done with the question. We want to try to figure out the concentration of the two things at equilibrium. Take that 0.00178 and plug it back in to either here to solve for the reactant or here to solve for the product. And if I do so, I would end up with a concentration of the Br2 diatomic bromine 0.065 and a concentration of the Br to be 0.0084. A lot of the problems we have will not be using the quadratic formula, so it will be simplified. However, I wanted students to be aware of that. And this question number 4 combines that quadratic formula use from the equilibrium part with the Q, the reaction quotient. Hopefully now you'll be able to do the last question on the reading guide, which is doing another problem in your textbook.